Let's take a look at lecture 2A. This is still an excerpt from the following. For this section, we're going to talk about the limits, derivatives, and integrals of vector functions. So we can extend the formulas to work on R to the n, n-dimensional space. So we're going to start with limits because it says here that we have to talk briefly on limits, derivatives, and integrals. So for limits, if we take the limit of the vector function r of t as t approaches a, then you simply take, ang ibig sabihin yun, you simply take component by component. You take the limit of each component as t approaches a. So you will now have limit of f of ti as t approaches a, plus the limit of g of tj as t approaches a, plus limit of h of tk as t approaches a. Where yung f of t is here, from this one, from the original value there, no? So mga components. So, again, all that we do is take the limit of each of the components function and leave it as a vector. So, ganyan. So that example, we have the following. Compute for the limit of r of t as t approaches 1, where r of t is this. T cubed sine of 3t minus 3 over t minus 1, and we have e to the 2t. So what are we going to do? According to the information that we had earlier, all you have to do is to take the limit of each component. So you will have limit of t cubed as t approaches 1, limit of the second component, sine of 3t minus 3 over t minus 1 as t approaches 1, and take the limit of e to the 2t, next one, as t approaches 1. But what is limit of t cubed as t approaches 1? Oh, this is a constant, no? 1. They're approaching 1. So they will have 1 cube. But what is 1 cube? 1. The limit now of the 3 cosine 3t minus 3 all over 1 as t approaches 1, you will have 3 cosine 3 times 1 minus 3. What is 3 times 1 minus 3? That's 3 minus 3. That's 0. What is 3 cosine of 0? Anong cosine ng 0?
1.
1. So you have 3 cosine of 0 is 1. So 3 times 1 all over 1 will give you 3. Correct? And then the limit of e to the 2t as t approaches 1, you will have limit of e squared. But what is the limit of e squared? It will simply be your e squared. Now, how about on the y component? It says here that we had to use L'Hopital's rule on the y component. Paano yan? You remember your L'Hopital's rule? So r of t, f prime of t, g prime of t, h prime of t. That means say you get the derivative for r prime of t. So when you take the derivative of r prime of t, isa-isahin din siya. No? Ang component per component din. So example, compute r prime of t, excuse me, for r of t. Wherein your r of t is t to the 6i plus sine 2t j minus ln of t plus 1k. So dapat memorize niyo yung derivatives. What is the derivative of t to the 6th? Kasi sabi niya, component per component ang pagkuha. Can you remember? Ano ng formula ng derivative natin?
Power rule.
Ha?
Na tong power rule, ma'am.
Yes, power rule. Correct. That's correct. Paano na yun? You remember? What's the derivative of what's the derivative of u to the n? Derivative of u to the n. Ay, naku, sorry. Derivative of u to the n. Power rule. That is n u to the n minus 1 du. Correct? So from here, you have t to the 6. So the derivative of that is 6t to the 6 minus 1, which is 5. Yes. How about the derivative of sine of 2t? Derivative, ang dapat i-memorize ninyo ito. D, C, N, S. Ang derivative ng cosine is negative sign. So, pag derivative ng sine is the positive cosine. So, ito lang memorize. Derivative of cosine, kasi usually generally dito sa derivative ng cosine at saka derivative ng sine. No? So, you associate the derivative of cosine is negative sine. Ayan. The derivative of sine therefore is positive cosine. Pero may 2t pa man. Cosine u du. So what's the derivative of 2t? 2. So that's why you have 2 cosine of 2tj. Correct? Hello?
Yes, ma'am.
Yes,
Nasundan?
ma'am.
Okay. Oops, sorry. Balik natin doon. Also, what's the derivative of ln? Can you still remember? Derivative of ln of u is ln of u is
1 over u.
yes, correct. 1 over u. Ayun, masulat kasi 1 over u. So, meaning to say ito, derivative ng, ang u natin is t plus 1. So, ang derivative ng ln of t plus 1 is 1 over u, which is 1 over t plus 1. Tama? Hello?
Yes,
Yes,
ma'am.
ma'am.
Ma'am, dili ka mag-chain rule
Isa-isa
na,
ha,
ma'am.
component, pardon?
Hindi po kayo mag-chain rule niyan.
Yeah, kasi 1 over u, du man. So, ang derivative ng t, dt, will give you 1 pa rin. Unless t squared itong dito. Diba? So, 1 over u, du. So, 1 over u, 1 over t plus 1, dt. But what is dt there? In terms of t, derivative t is 1. Okay? So, mag-chain rule lang pagka meron pa kang, kahit mag-chain rule tayo, lalabas pa rin 1 over t plus 1 because of this. Pero for example, t squared itong tito, then you will have, ang derivative niya becomes 2t over t plus, t squared plus 1. Nakuha?
Yes, ma'am.
Okay, sige, good. Now, let's take a look on the basic facts that you know about your derivatives, just in case you forget. So, ang derivative ng mga vectors ito is simply u prime, v prime. Derivative ng cu prime is you take the constant out there and you just take the derivative of v prime. If you have derivative of a product, take the first factor, multiply it by the derivative of the second factor, plus take the second factor, multiply it by the derivative of the first factor. Pag dalawang vectors, then u prime v plus u vector v, then you have v prime of the other vector. Pag multiplication, this one. You take the u prime cross v plus, then you take again u, then you take the v prime vector. And if it's this one, if it's a function in terms of f of t, then you will have u, f of t will be f from t vector prime u, f of t. So chain rule pa rin itong dito. Let's take a look at a smooth curve, which is continuous, but r prime t is not equal to 0. So a smooth curve is any curve for which r prime t is continuous and r prime t is not equal to 0 for any t except possibly at the endpoint. So an example of that is your helix, which we had seen earlier. So pagdating naman sa integration ng r of t dt, ganun din ang gagawin. Di ba sa limit, ang ginagawa is isa-isahin ng component. Sa integration, ganun pa rin. Isa-isahin pa rin. Component per component pa rin ng pagkuha ng integral value. So you have to take it component by component. Plus this time, if it has no limits of integration, then you can have plus a certain constancy. For definite, pag may limits of integration from A to B there, then wala na yung plus C. You simply evaluate it at that function. So, component per component pa rin ang pagkuha ng integral. Another example before that. So, with the indefinite integrals, we put in a constant of integration to make sure that it was clear that the constant in this case needs to be a vector instead of a regular constant. Okay, meaning to say, do the indefinite integral and then do the evaluation of the vector as a whole instead of on a component by component basis. So after nyan, at saka isulat yun. Kunin niyo lahat mo na integral niya and then at saka ninyo i-evaluate as a whole. Example 3, compute for the integral of r of t dt for r of t is the given vector function, sine t6 for t. So integrate each of the components. So anong integral uli ng sine t? Okay? Can you remember anong integral ng sine t? Anyone? Basic yan siya. So, sinong makarecall? Di ba kanina sabi ko, ang tandaan nyo po for derivative, DCNS. DCNS. Pag integral of sine is nisi, is negative cosine. So, integral ng sine is negative cosine. Ano integral ng 6? Becomes 60. Why? If you remember, you have integral of u to the n du. Integral ng u to the n. Hello, class. Are you still with me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, from current slide. So, if you remember, diba, ang integral ng u to the n du, u to the n plus 1 plus, tapos over, no? Over n plus 1 plus c. So, kunyari ito, 6. 6 lang yan. So, 6 to the t to the 0. So, kaya maging siyang 6 to the t to the 1 all over 1. So, you have 60. 4t squared, integral niyan is 4 to the t. So, 1 plus 1, that's why you have t squared all over 2. That's why 4 divided by 2. So, you have here 2 na lang there. Is that okay? Naintindihan bakit nagkaroon ito ang integral? Hello? Hello, class? Hindi ba ako na... can you still hear me?
Yes, ma'am.
Okay.
Yes, ma'am.
Ma'am, unsay purpose sa plus C?
That is the formula for inyuhang walay limits of integration plus C, vector C. Diba, remember niyo ang formula ng integral?
Yes, ma'am.
Oo. Diba na ay permanent constant C. But in this case, kay naman to sa vector valued function, ay yung C now is actually a vector here. Plus C, vector na. Pero sa original, if you remember sa integral natin, basta walay limits of integration diha, then you will always have a constant C there. Okay? Yeah. This one, pag meron pag may limits of integration na dito, then wala na yung C. You simply substitute the value now from, you will have the upper limit minus, kaning upper limit minus the lower limits. Substitute mo na yun. So, for example, number 4 here, what is the integral of sine t? Diba? Sinolve naman natin dito kanina. Sine t, 640 man yun. So, but in this case, it says, it's evaluated from 0 to 1. Dito wala mang limits of integration dito. Wala. Pero ito, meron na siyang limits of integration. So, hindi na natin gamitin yung plus C dito. Wala na. What you're going to do now is to substitute ng value. So, negative from here, you now have from 0 to 1 na. So, yun pa yung answer. Pareho nito. Negative cosine t, 60 plus 2 t squared plus C, 0 to 1. So, from 0 to 1, mean to say, substitute negative cosine 1, okay, minus, ito, sunod is, ito, substitute number yan, minus cosine of 0. So, you have negative 1. Then ito, 6. So, you have 6 times 1. So, you have 6. 2 times 1. So, you have 2 times 1 squared. I'm sorry. So, you have 2. Then, so substitute ang 0. So, negative cosine of 0 says what? You have negative 1. Then 6 times 0, so you have 0. 2 times 0, so you have 0 there. And then subtract. So you have negative cosine 1 minus 1, that's plus 1. What is cosine 1? Negative cosine 1 is still your cosine 1. Negative cosine 1. Ito. Negative cosine 1 unless gamitan nyo ng point values. Okay? So, you can rewrite it as simply negative cosine 1. Negative cosine 1 minus of minus 1 there, minus of 0 is 0. So, you have negative cosine 1. And then you have 6 here, minus of 0 again. So, you have 6 component by component, diba? Negative cosine 1 minus of minus 1. So, that's plus 1. So, kaya 1 dito na una, plus 1, minus cosine 1. Then, 6 na po, minus of minus by component 0. So, you will have there 6. Then, 2 minus of 0, what you have? That's why you have 2. So, the same manner, by component pa rin yung pagkat. So, in this case, yung negative cosine 1, yun pa rin negative 2. Unless, i-compute ninyo sa calculator yung cosine ng 1 ninyo. Okay? So, maging, instead of negative cosine, it will be a different value. And you can rewrite that one if you want. So, these are the examples for this one. I guess nag-end na yan dyan. Last na yan. Okay. Let me stop presenting and let me stop recording.